Okay, dear student, let's see what is there in this question. Identify the laws of conservation that are represented by Kirchhoff's law. Okay, so Kirchhoff's law is consisting of two laws. Number one is the junction law. Now, junction law is that, let us say this is the junction, like wires are connected at one particular point. So I1 is the current here, I2 is here, and I3 is here. Clearly, I1 plus I2 will be equal to I3. So that we usually know and we usually consider it, but we do not know it from the point of view of conservation of something. Let me tell you, this principle is actually the conservation of charge. So current is rate of flow of charge. So current is actually telling you how much charge is flowing in the wire in 1 second. So if this much of the charge is entering here, this much of the charge is entering from the other side, obviously charge cannot be created nor destroyed. Where the charge will go? This is charge conservation principle, and so the charge will be conserved. So number one is charge. But that's not the complete story. Now, what is the second Kirchhoff's law? The second law, it becomes loop law. It is known as loop law, and it is also known as potential law. You can say like the sum total of all the potential differences across in one loop, it comes out to be equal to zero. So basically, it is the conservation of energy principle, because in this case we talk about the energy given by the battery and the energy which is consumed by the circuit, by the various elements in the circuit. Technically it is this, but later on, like, there are various formations of the Kirchhoff's law. So the formation that we use, in which we are going to draw a loop, and then we find the v is equal to IR and all that. So that is done from the point of view of unit positive charge, so we call it potential rather than the potential energy. That is the only thing. So there will be two laws. Number one is the conservation of charge. Number two is conservation of energy. I will show you the answer later. Let us move to part B first. The cell is connected to the ideal voltmeter. Okay. This is ideal voltmeter. So there are many students, those who say, sir, how do you recognize that the voltmeter given the circuit is ideal? My dear students, only ideal voltmeter is in our syllabus. So it cannot be anything else. Number one. Number two, this is the way that they show ideal voltmeter. Simple. So ideal voltmeter is having infinite resistance, and so in spite of being connected to the circuit, current is not going to enter into the voltmeter branch. That is for sure. Now the cell is connected to the ideal voltmeter, a switch S and a resistor R. The resistor of R is 4 ohm. When S is open, when S is open, the reading of the voltmeter is 12 volt when S is open. Okay, so current is not flowing. It means the current is not flowing in the lower branch, and the current cannot pass through the voltmeter. It means that this battery is there, EMF is there, internal energy is there, but current is not there in the battery. And the voltage difference across a battery is given as 12 volt. Now, very important point. What is EMF? How it is defined? EMF is the potential difference across a cell or a battery when no current passes through it. Simple. So voltmeter will be there because you want to find the potential difference across the battery, but the current should not be passing. Because if the current starts passing, it will be facing the internal resistance R, and some energy will be consumed by the battery itself. So the battery of EMF 12 volt will actually not be acting as 12 volt battery. Why? Because 2 volt out of those 12 will be consumed by the battery itself. So your circuit will be having only 10 volt of the potential difference at its disposal. That is why. So in this question, you can clearly see that the current is not flowing, but the voltmeter reading is 12 volt, which it means to say that the EMF is 12 volt. Another way of telling you that the EMF is 12. Okay, now let's move next. Now, when S is closed, the voltmeter reads 8 volt. Now S is closed. Now, if S is closed, the current will start moving through it. So how the current will move now? Let us see. So current will start moving. It will move like this, like this. But at this junction, current is not going to enter into voltmeter because the resistance of voltmeter is infinite. So current is going like this. It will pass through the resistor like this, like this, like this, like this, and then it goes to the battery back again. So this is the loop in which the current is going to move through. Okay, now another very important definition: terminal voltage or terminal potential difference or terminal voltage, one is the same thing. So this is the potential difference across the battery when current is not zero, when current is not zero. So that is the potential, that potential difference is called as terminal voltage difference. That is what I told you, that out of this 12, let us say 2 volt or 3 volt, like clearly it is giving 8 volt reading. So this reading, it reduces to 8 volt. It means 4 volt of the energy is used by the battery itself, by the battery itself. So your external circuit, it will say that I am applied across the battery of EMF 12 volt, but I am not getting the equivalent current. The current which is passing through this is equivalent to 8 volt. Ironically, isn't it? Why is that? Because there is internal resistance. There is a difference between EMF and potential difference, terminal potential difference. Okay, having said that, now I would be now giving you the formulas for the terminal potential difference and others. Now there are two things that you have to remember here. The first is discharging. So discharging means that this is the battery and current is getting out of it. That is called discharging. So current is withdrawn from it. EMF is E, internal resistance is R. So the potential difference across this battery, like let us say the point A and point B, it is given by E minus IR. And how you can derive it? You can derive it with the help of Kirchhoff's law, but I believe you're not interested in that, isn't it? So just take this formula. VAB is equal to E minus IR. Okay, that is discharging. So in this case now, let us go for the question. Okay, let me tell you about the charging also. In the case of charging, what happens, like this is EMF, this is internal resistance, this is the current I. So if this is the case, the current is entering into the EMF, entering into the battery, the potential, the terminal potential difference becomes E plus IR. That is the potential difference across the battery when current is passing through it and it is charging the battery. It is entering into the battery. So this formula comes. So there are a couple of questions in IB previous years. Those who are using this formulas also. But in this question, this formula will not be required. So I am getting rid of it. I'm removing this thing. If you want to note it down, you can just pause the video and move back. So this 12 volt is the EMF. 8 volt is the terminal potential difference. I is the current which is passing through it. So I can say that 8 is equal to 12 minus I into R, where R is not known and I is also not known. Okay, no problem. We will be concentrating on the resistance R now. So the voltmeter says 8 volts, so that will be across the resistor also. So V is equal to IR. We will find the current first. So V is equal to IR, 8 4 into R. So the current is coming out to be 2. So 2 ampere current flows through this circuit. Accordingly, if I substitute this value here into the internal resistance, so 2R is equal to 12 minus 8, 4. So this R is also coming out to be 2 ohm. So 2 ampere is the current and 2 ohm is the resistance of the battery. Let us now see what are they asking. Like first question is state the EMF. State the EMF. State means you need to give the definition. So I've given you that definition. Okay. Let us see. Deduce the internal resistance. So we have done it. 2 ohm. I would be coming back to the first question later. See, the voltmeter is used. Yeah, we will do that question later. Now, state the EMF of the cell. So I have already given the statement for that, but there is one more thing that you need to note. Let us go to the mark scheme. I show you. Okay, so our answer is A, the conservation of charge, conservation of energy. EMF of this is 12 volt. Okay, they are not giving the definition. Oh, I thought that the definition of the EMF has to be given. So I was saying that when we define EMF, usually IB books are not defining EMF the way I have given you the definition, which is more explanatory by the way. But that definition is not given. EMF is defined as the work done in taking a unit positive charge from one terminal of the battery to the another terminal of the battery through the circuit. That is the definition that usually it is given in IB. So if IB or the examiner in IB is asking you what is EMF, this is the definition that you need to give. But this definition is not having any practical use. It's only for writing. The definition that I have given you earlier, it is practically important. So you must remember both of them. Now, current is 2 amperes and the resistance is 2 ohms. So this is what we did. So A, B is over. Let us now go for C here. Okay. The voltmeter is used in another circuit that contains two secondary cells. Okay, I was telling you that there are questions where the charging of the battery is taking place, but indeed, even in this question also, we would be using the same formula. Now, I will show you the difference. I will explain you properly. Now, what is happening? See, cell A has an EMF of 12 volt and the resistance is given. Calculate the reading of the voltmeter. Current is not given. So we have to first find the current that is passing through it. Yes, we would be finding the current first of all. So the current will be going like this. Why? Number one, the voltmeter branch will not be having any current. This battery is 10 volt and this is 4 volt. So 10 volt is like current is withdrawn from 10 volt that is given to 4 volt. One out of these two batteries has to be charged. Like otherwise the current will not be flowing, but this battery voltage is bigger, greater, so obviously this will be able to create a current and it will be able to push through 4 volt. So cell A is undergoing discharging and cell B is undergoing charging simultaneously. So the voltage is going into the another cell. This is what is happening. So we will apply Kirchhoff's law, simple, and we will try to find what is the current that is moving through it. Okay, so the loop will be this, and I assume the direction of the current to be like this. So this is the negative, this is the positive. So I will not be explaining you how to apply the Kirchhoff's law. So you can see my other videos that I have created. They are already present in the playlist, and I have completely given you the explanation of Kirchhoff's law. So please refer to those videos. So I'm starting from this point. So it is a negative terminal. So it will be plus 10. The loop goes to this point, which is the positive terminal. So it will be minus 4. Then the direction of the current and direction of loop is same. So minus 2 into I. And then I'm going directly to this. And the direction of the current and the loop is again the same. So minus 1 into I, that is equal to 0 because I have reached the same point back again. So 10 minus 4 is 6, minus 3I is equal to 0. Clearly the current is coming out to be 2 amperes even in this case. So current is 2 ampere. Now calculate the reading of the voltmeter. Now there are batteries, there are internal resistances, and current is also passing through it. It means we are not talking about the EMF anymore. EMF is 10 volt, EMF here is 4 volt, but we want to find the potential difference across both of the batteries. So for cell A, discharging is taking place. And let me show you like what will be the value here. Discharging is taking place and Vt is given by E minus IR. E is 10. I now we know I is 2 amperes, R is 1. Clearly it is 8 volt. So it is 8 volt reading that we have in the voltmeter even now. Okay. And earlier also it was, by the way, 8 volt only, but these two questions are qualitatively different, I would say. So this is 8 volt. So this reading here is 8 volt. Now let us also try doing this question with the help of charging and see if we are getting the same answer. So E is 4 plus current is 2, this is 2. So 4 plus 4 is 8 volt. In both of the ways, whether you are using the principle for discharging or you're using the principle for charging, in both of the cases, the terminal potential difference is indeed coming out to be equal to 8 volt. So this is how we do it. So this is how we do it. Calculate the reading on the voltmeter. So the reading on voltmeter is coming out to be 8 volt. Okay, let's now see what is given in the mark scheme. Yes, the answer is 8 volt. So this is done. Let us go to the last question, probably, I believe, 4.C2. Comment on the implication of your answers to C1 for the cell B. So, for the cell B implications, clearly our answer for this will be what could be the implications? Like from the point of view of the potential difference across cell A, in which we have applied the principle of discharging and we found that the voltage across the battery is coming out to be 8 volt. So implication for cell B will be that when the potential difference is 8 volt, this is positive, this is negative, and the battery is 4 volt, clearly the current will be entering into the cell and thereby charging the battery rather than reducing the battery. That will be the implication. Let's see what is given in the mark scheme. Charge is being driven through the 4 volt, hence it is being recharged. And that is what I said. Let us go to the next question. Oh, 4D is also there. Okay. Oh, E is also there. Oh my God, it's a very long question. Yes, electricity can be generated using the renewable resources. So qualitatively, now completely the topic is changed. In this case, we are talking about the topic 8 now. Electricity can be generated using the renewable sources. Outline why electricity is a secondary source of energy. See, a secondary energy source. So primary is the one which does not need any refinement, and we can just get it out of the earth or something, and we can directly employ it for producing power. But electricity is secondary because you need processing for that. So first you would be burning a primary source and then electricity will be generated. Like you are burning coal in thermal power plant and electricity is generated, and then you are using electricity for certain things. So that is why electricity is the secondary source of energy, because it is at the second level, not at the first level. Okay, so that is the secondary source of energy. Let's see. Some fuel sources are renewable. Outline what is meant by renewable. Even this question can be answered easily. Renewable means that the energy sources which can be replenished after some time easily. So that is known as renewable resources. You better know how to answer this. Let us go to the 4D. So the answer is generated from the primary source. So secondary sources are those sources which are generated by the primary sources. Clear? And 4D2 is a fuel that can be replenished, replaced, and all that. We are like their fuels are limitless, etc. Now, V1. A fully charged cell of EMF 6 volt delivers a constant current of 5 ampere for a time of 0.25 hour until it is completely discharged. The cell is then recharged by a rectangular solar panel. Dimensions are given, where maximum intensity of sunlight is 380. Overall efficiency is 18%. So, first of all, what is the power incident? That is given by 380 watt per meter square, but out of this only 18% is usable, other is wasted. So what is the energy gained? I would say 380 watt per meter square multiplied by the area and this is multiplied by time, that will be the energy. This is the power, this is the area, like watt per meter square multiplied by meter square, it is watt. You multiply by time, it becomes joule. So this is the energy, but out of this total energy only 18% is usable, like it is converted by the battery. So 0.18 factor will also be there. So this is the energy which is taken from the sunlight, and we want to charge our battery. What is the total energy with the battery now? So the power formula is V into I. So energy can be taken as V into I into T. So voltage is 6, current is 5, and the time is 0.25 hours. Hours means it has to be multiplied by 3600 seconds. So this is the total energy that can be stored in the battery. So we would be equating these two and we will find the value of T. This is what we're gonna do. So I would be using my calculator now. 5 6 are 30. 30 into this 0.25. So this is coming out to be 27,000 divided by 380.4.15.18. So the answer is coming out to be 6578.94 seconds. But we want to like give the answer in kind of two significant figures. Yes. So it can be written as 6579. So it will be 6.5 into 10 raised to power 3 seconds. So this will be our answer. And let's see what is the answer given by IB in the mark scheme. 6.5 into 10 raised to power 3. Okay, energy output of the panel is 27,000, exactly what we did. 380 multiplied by the area multiply 0.18, and this is divided by 0.4. They are getting the answer as 6600. Yeah, approximately correct. We are getting 65 something. So my answer was 6.5 into 10 raised to power 3. Accordingly, you can find this answer. I don't know why. Like sometimes, calculation gives you more or less a similar kind of answer is there. Okay, I don't know why there is a bit difference that is coming here. Okay. Anyways, you can do this thing now. Okay, let us see what is there in the next question. Outline why research into solar cell technology is important to the society. Okay, so this is just a general question. You can answer it by yourself um, because they look beautiful. No, not like that. Because we are facing an energy crisis and we need to find more of the renewable energy sources, etc. Again, okay. So the current reason to improve efficiency, non-polluting, renewable. Okay, dear students, thanks for watching. This is Professor Varun. Please share the video with all of the students. See you in the next video. All the best.